This is 6.2, using Newton's second law. So I've written out Newton's second law. F net is equal to the sum of all forces on an object of F sub I. That's what we mean by F net. And that's supposed to be equal to the mass of that object times the acceleration of that object. Now, this whole chapter is titled Motion Along a Line. But that doesn't mean that all of our forces are going to be lined up, okay? So here's a situation, say, where there's 3 forces in a problem, and they're all lined up. Nice and simple, but we're going to be doing more complicated situations where the forces aren't all along a single line. For example, they might look like that. And then you go, well, wait a minute. Motion along a line was the title of chapter 6. Yes. In chapter 6, although the forces can point in all sorts of directions, it's going to always simplify to whether it's like a railroad track or an ice rink or some other situation where the particle is confined to moving back and forth along a single line. And that, though, does not mean that all the forces on the particle act along that single line. So you're going to end up with a situation like this, and then you're going to choose your axes very carefully so that the problem is simple. And the typical thing to do, let's say this was actually, for example, in that previous example I did, a car on a hillside. Well, make your life easy. Choose one of the axes to be perfectly parallel to the hillside. And then the other axis, of course, is perpendicular to that. So now we have x and y. And then, using Newton's second law, what does it amount to? It amounts to resolving these vectors into vectors that point along this axis that you've chosen. So here, this vector already points along this axis, but this vector here has some component in that direction. And this vector here already points along the y-axis, but this vector here has also some component in that direction. So using Newton's second law amounts to resolving the vectors into components along each of the axes. Now I've written out what that amounts to is a vector equation. Okay, this still has the I hats and the j hats in it. So this is a vector equation. The immediate next step into turning it to an algebraic equation is to say, oh, f net sub x must equal ma sub x, because that's what multiplies I hat on both sides of the equation. And f net sub y must equal to may, because that's what multiplies j hat on both sides of the equation. And of course, when we get to 3D, there's also going to be f net z is equal to ma z.